For years, the electric vehicle sector has been at the forefront of sustainability and energy efficiency concerns. Tesla has been at the forefront of this movement with their groundbreaking electric motors, which have been hailed for their unmatched performance, long lifespan, and low-maintenance design. But just when you thought things couldn't get any better, they did. Once more, Tesla has pushed the envelope of what's feasible. Tesla's newest motor, which Elon Musk recently presented, is already wreaking havoc on the industry. It's time to see how this innovative drive unit promises to transform the industry forever and unquestionably revolutionize the way we think about electric vehicles. Conveyance. Before we delve further into these topics, please hit the like button to demonstrate your support for Wall Street profits, and the subscribe button. Since the company's inception, when it was first established as Tesla Motors and was led by Elon Musk, who has served as the company's product architect from the start, Tesla has been creating its drive units. With the release of Tesla's model in 2012, the drive unit was brought entirely in-house and no longer licensed technology from third parties. Tesla's innovative approach to engineering and manufacturing has allowed it to remain at the forefront of the industry. The original Roadster, designed nearly 2 decades ago, contained power electronics in a drive unit that was built and designed by Tesla, but licensed technology from AC Propulsion, which was the proof of concept at the time. Two of the most cutting-edge and effective electric motors available are the permanent magnet and induction motors made by Tesla. In an induction motor, a series of electromagnets are used to create a rotating magnetic field that in turn induces an electric current in the motor. This force drives the rotor, producing rotating mechanical energy. Compared to other types of motors, the induction motor's design is relatively simple and has fewer moving parts, making it highly reliable and low maintenance. Nikola Tesla invented the induction motor, which is still one of the most widely used electric motors today. However, unlike induction motors, permanent magnet motors have a set magnetic field, which makes them they are therefore perfect for use in electric vehicles where dependability and efficiency agency are essential because they are reliable and efficient when operating. Additionally, Tesla has created a new kind of engine for its plate vehicles, which include the Tesla truck and the Model S and Model X plate. We're excited to see what Tesla has in store for the future of electric mobility, as the new motor promises to push the envelope even farther. In addition to power acceleration and low energy consumption or efficiency, Tesla has always been a company that innovates on features that are visible to customers. However, one of the most significant innovations that frequently goes unnoticed is building high-quality products. While keeping costs low takes a great deal of work, but it also means that more people will be able to access and utilize Tesla's technology. Despite the moniker being used in all of their vehicles, Tesla has already started cutting prices in their Model 3 engine. From 2017 to 2022, they lowered rare earth metals by 25%, eliminated 20% of the weight, and remarkably reduced the manufacturing area needed to make these motors by 75%, which contributed to a 65% cost reduction. Increasing the factory is another essential component of lowering the cost of the motor itself. At Tesla's recent Investor Day, car specialist Cindy Monroe and his team noticed that Tesla is using a hairpin electric motor design, which further improves efficiency and lowers cost. The cost of the factory itself often ends up within the cost of the product, since Tesla needs to charge enough to cover all of their expenses. Because this design uses rectangular wire rather than the more common round wire, more copper may be accommodated in the same amount of area, making the motor more efficient overall. Electric motors are a necessary component of electric vehicles, and hairpin motors are a relatively new technology that's been gaining traction in the automotive industry. Unlike traditional electric motors, Tesla's focus on extreme scale and reducing costs while maintaining high-quality products are truly innovative and game-changing in the automotive industry. Hairpin-shaped stator windings are used in hairpin motors, which improve heat dissipation and reduce wind resistance. These windings also enable a higher copper fill factor, which produces a stronger magnet and, consequently, a stronger motor. Tesla has lately joined the ranks of numerous well-known automakers that have already incorporated hairpin designs into their electric cars, including Volkswagen, BMW, and General Motors. Tesla can swiftly iterate through millions of designs to select the best one because of its proprietary software, which is quicker and more accurate than competing tools. Because that can be used to optimize hairpin technology, this program is also ideally suited for it. The motor's resistance is decreased and overall efficiency is increased by the hairpin winding arrangement. A significant obstacle in the application of hairpin technology is the precision involved in the bending and welding of the copper hairpins. In order to solve this problem, Tesla developed automated machinery that is currently in use to assemble these motors. This is a significant achievement because improperly welded hairpin ends can result in electrical losses that can lower the efficiency of the motor. Another innovative feature is the Tesla charging chip. Tesla constructs their superior suggestions from experts and within the company. Despite these changes, the chip still has the same, if not better, capabilities, making it a significant technological advancement. Tesla chips are unmatched in the industry. They have been able to reduce the amount of heat by 2 times and reduce the number of microprocessors from 4 to 1, making the chip smaller. At Tesla's Investor Day, the company demonstrated how its dedication to software design and vertical integration has allowed them to push the envelope of what is feasible in the electric vehicle business. Colin Campbell underlined their capacity to manufacture all 100 of their premium car components internally, all while maintaining an organizational structure that encourages involvement and communication from all parties involved. Even software is used by Tesla to design hardware, drawing from its Silicon Valley heritage. The revelation that Tesla's next-generation motor will consume 0 rare earth metals was one of the event's most remarkable disclosures. This has caused some doubt in the rare earth metals sector. With businesses like MP Materials seeing a decline in their stock prices, it is a credit to Tesla's engineering prowess that they were able to eliminate these pricey and challenging-to-source elements without compromising performance. Neodymium, praseodymium, and dysprosium are the metals that are commonly found in Tesla's permanent magnet motor. Tesla previously used 500 grams of one unidentified rare material and 10 grams of 2 other rare materials in each drive unit. Tesla did not specify which metals these were. These metals cost more than $100 per kilogram or more than $100,000 per ton. By removing rare earth metals, Tesla will potentially save hundreds of millions of dollars, billions of dollars over time. Hairpin-shaped stator windings, which lower winding resistance and improve heat dissipation, will also be used in Tesla's next-generation motor. Companies like Volkswagen are still researching this technology, but the hairpin windings also allow for a better copper fill factor, which means more copper can be packed into the same space, resulting in a more powerful magnet and motor. Tesla is joining BMW and General Motors in incorporating into their electric vehicles. Tesla has been able to optimize their motors and cut costs in other areas thanks to their dedication to software design. Compared to other competitors, but the next-generation powertrain will enable Tesla to reduce expenses and rework their constituent parts. Sandy Monroe and his group claim that the full next-generation drivetrain will only cost $1,000, which is a substantial discount from what their rivals charge. The next-generation vehicle will be smaller and lighter. So Sam Corres from ARK Investments estimated that a battery pack from that vehicle could cost roughly $5,000, plus $1,000 for the new powertrain. However, the battery size used in this calculation seems excessive because Hedgehog's response with a 45 kilowatt-hour pack is more accurate, resulting in a powertrain cost of $41,100 and a vehicle cost of $16,000. What's amazing about Tesla is that they can construct everything themselves, which makes them stand out from their rivals who are busy procuring software and parts as they close the gap. This closes the film. Thank you for watching to the end, and we'll see you in the next international video. Tesla's next-generation motor will be on exhibit even more, and this design will probably become the standard for most of their vehicles.